We have an excellent working relationship with the Austin District. We've worked very closely with Mike Ariano, who's the pavement preservation engineer, and he's a great person to work with. He's always coming up with new ideas, innovative ideas, and we really do enjoy working with him. This particular project that we worked on with Mike was led by Dr. Randy Makamel, who's in the third row right here, and a couple of his students, Ahmad Arashadan and Jacob Gutkunst, which Jacob is since, I keep saying retired, but graduated is the correct word. He's graduated, so Ahmad is currently working on this project. But the idea, as I progress into this, is we've spent quite a bit of effort providing tools for Mike for developing the 4-year plan, for analyzing his PMIS data, for looking at lots of different kinds of data, and he's now has a GIS-based system for looking at his plan in multiple different ways. And as I mentioned, he's always coming up with new ideas, and his idea was, how can I look at the impacts of commercial construction, residential construction, or industrial construction that may be happening off in the future, but I want to take it into consideration how it might be impacting particular projects in my plan. So that was a very interesting challenge, and one we like to, the kind of things we like to do, like to work with Mike. So really that's what this is about. It's not about early warning systems for work zones, as we pointed out. So talk a little bit about the 4-year plan, then some of the things we needed to think about with regard to construction truck damage, and being able to think about that into the future and how that's going to be impacting your 4-year plan. Now I call that a 4-year plan because that's essentially what every district has right now, a 4-year pavement management plan. But like I said, Mike is forward thinking, and we're working with him now on a 10-year plan to manage his pavements. And so we'll talk about that, how you look at how these different kinds of construction projects could impact your planned pavement projects. Then we did a case study looking at fracking. There's 3 counties in the Austin district that has fracking operations ongoing, so that was a case study that we conducted. So again, the 4-year plan, as I mentioned, this is a static view of the GIS platform, but Mike has the ability to turn on and off all different kinds of data. So this plan is basically showing the district and each project for each year of the plan. You can click on that project and it'll tell you what that project is in terms of the type of construction that's ongoing, who's over that project. He can also turn on and off distress data, condition data, change in distress and condition between now and previous year, skid data, crashes. We've developed a road safety performance index, so there's all kinds of overlays that Mike can put with this. And then the next thing again is, how do we take into account impacts due to construction? So this is an example that we talked to Mike about, and we first talked about either commercial or residential construction. This is an apartment complex. Oh, I don't even have the microphone on. Can you, I guess you can all hear me okay. Okay. Let me see here. Whoop. There's the pointer. Well, yeah, okay. So this is an apartment complex. This is Mopac, which is a major crosstown expressway in Austin. This is Camp Mabry, for those of you familiar with the district. And this is a big apartment complex that was being constructed. This is a local street, Bull Creek, and I travel that every day. And so actually, as this was being built, I got to see what the impacts were to me, my car, and how the condition of that roadway changed over time. But we're interested in this in that it helps us see the different phases and what kinds of trucks, how many trucks, what kinds of heavy equipment is coming in at different phases of the construction. So this is phase one. They're doing the local earthwork, and they're, of course, bringing in heavy equipment, bulldozers. A D10 on its transporter weighs about 200 to 240,000 pounds. And of course, so you have different sizes of equipment, different kinds of equipment that has to be brought to the site, and you have truckloads of earth. And as you progress, you start doing drill shafts for the foundation of, in this case, the parking garage, and you're bringing in ready-mix trucks, which weigh 69 kips each, unless it's a SHV with the additional axles. Then you're doing utilities. Then you're bringing in prefab panels to build the parking garage, and additional site work to start the foundation for the apartment complex itself and preparing for the parking lot. You're bringing in concrete for that, and you're bringing in wood trusses, and I've got circled there. You start seeing patches are showing up now in the project as repairs are being done, and this is actually right at the project. The roadway was actually in better condition than back up the roadway, and I can attest to that for what it was doing to rattles in my little Toyota Corolla as I was driving along this route each day. And then further construction on the apartment itself, and finally the roofing and so forth. So there are identifiable phases, different identifiable kinds of equipment, truckloads of materials, and numbers of truckloads of materials that are necessary to build this apartment complex. What impacts is that additional traffic going to have on a project that you've got planned maybe for next year? Do you need to change the timing, the design, or a project that you've got 2 years in the future if you've got another apartment complex that's going to be built in the area? So that's the focus of this study. So if you're talking about commercial or residential construction, you can get construction permits from the city. They provide a lot of basic information about the proposed time frames and so forth, the type of construction, and we anticipate that likely what we can do is, knowing the size of the apartment complex, how many units, we can convert that into numbers of truckloads of different kinds of materials. What are the origins and destinations for the different kinds of materials, ready mix, hot mix, lumber, and so forth? And then how many equivalent single axle load applications are we putting on these different routes depending upon what the origins and destinations are? And then is it impacting a planned pavement project? Should the project be delayed? Should it be accelerated? Should you add a project on a route that's going to be receiving heavy traffic from this construction? So we again talked to Mike about the idea. He said, let's do a case study, but instead of doing construction for commercial construction and residential, I want you to do fracking. So we started looking at 3 counties, Caldwell, Bastrop, and Lee counties, which are part of the Eagleford Shell region. And we looked at, again, just like we just described for the construction of residential, what are the different kinds of heavy equipment and materials that are going to be needed to do the fracking. And so we started identifying the sources of the information. For fresh water, which is required for fracking, we got that from TCEQ. Where are all the freshwater well sites in the district? For quarry, for sand, where are all those quarries located, or how many are there? We got that from TxDOT. And then for saltwater disposal, where are the disposal wells? So we gathered that information and we started plotting that in a GIS platform. We got the quarry information from TxDOT. We ended up with 84 quarry sites, not only within the district, but outside the district, but adjacent to these counties. And we also found that there's actually a public website where you can go, and this is national, but you can go to Frac Tracker and look at TxDOT, and you can zoom in and you can identify where are the quarries that produce frac sand. and other kinds of materials. So we were able to get that. That information gives you the location and the GPS coordinates of each quarry site. And that's an example. We then got the freshwater well locations for each of the different frac counties, and we're pinned them down with GPS coordinates. The water injection or wastewater or saltwater injection wells, where are they located? And then finally, the wells themselves, where the permits were obtained from the Railroad Commission, where is a new well plan to go in. So we were able to put together all this information, which essentially are your origins and your destinations for the truck trips. And we ended up with the locations for 514 water wells, 84 quarries, 317 disposal wells, and 600 well permits. We realized that we needed to look at not only the locations of these different facilities within the district, but outside, because the closest location for, say, water for a well inside the district might be a county that's outside the district. So we had to look at both ways. Again, once this was put in a GIS platform, we had all the origins and destinations, but then how many truck trips would each of these activities generate? We used information that was developed through a CTR study conducted or led by Yolanda Protzi and a couple of students and Jorge Protzi, where they looked at the energy sector and specifically looked at the kinds of equipment and the truckloads that are associated. This is a typical frac site with the different kinds of equipment that are there. We also obtained from the Texas Department of Motor Vehicles, from TexPros, the oil well equipment for 3 years, all of the oil well equipment movements in the state and what they were and how much they weighed, so we could understand how much the heavy equipment that was being brought in first to actually put the well together, what that weighed. And again, it tends to be very heavy. It's relatively few trips compared to the actual fracking operation, but the weights of these loads can be quite high. They're usually unusual or unique configurations, so it's a little difficult to try to apply the AASHTO's equivalent single axle load concept to these kinds of vehicles, but we do recognize that they need to be considered, and in particular from a different perspective, not just loads on the pavement, but safety. And as the presenter in the last presentation showed, there are concerns anytime you have heavy truck traffic, heavy oil well equipment traffic running along narrow roadways without shoulders. You have concerns about edge drop-offs, edge failures, and the crashes that can happen. So there could be in the future a safety component that's looked at in addition to the impacts to the projects due to loadings. So again, from the research and from additional analysis, we had an idea for a particular well, how many truck trips, how many of different kinds would be necessary to produce one well or multiple wells. And we used that information, and then in the conceptual framework for the GIS system, we were, since we knew where all of the different activity components were located, we could plot those out, then determine shortest trip lengths between each well and each of those three types of materials: sand, water, and injection. We then could assign how many truck trips and then how many easels were going to be traveling along that shortest route. And we then generated a list of here are all of the routes in these three counties that are going to be carrying at least some level of oil field traffic. And so we generate those trip tables. We identify those that really aren't going to be carrying that many truck trips, and we focus on the ones that are carrying the heaviest loads. And then we do more analysis of those particular sections. So this is an example of kind of what you get in the GIS platform methodology. As I said, the ArcGIS itself has the ability, there's an algorithm within ArcGIS that will tell you what the shortest path is between an origin and a destination. So it runs that algorithm for you. So we can determine what's the shortest distance or shortest route on your roadway network between this well and a freshwater site, between this well and a saltwater disposal site, between this well and a quarry, and you just overlay all those. So you start stacking truck trips for all the wells that are in that sector until you identify where your critical routes are. And in this process, we identified 3 critical routes, State Highway 21, FM 1624, and US 77. State Highway 21 had 24 wells, so 24 wells times the number of easels for a particular type of operation. In this case, 24 wells times 686 easels per well for quarry operations, 24 wells times 1,456 equivalent single axle loads for water well disposal, and then 19 for freshwater. And there's a difference there because the shortest route may not be this route for every well that you're looking at. So you might have differences there. So in this particular instance, that section of roadway would, under full operation of fracking, would have about 120,000 easels applied to it. Now, your question is, over what length of time? Well, based on the information we've obtained from the Railroad Commission and other sources, from the time a permit is issued, and this is when fracking is in full sway, and we know right now that it's because the price of oil is down that fracking operations have slowed down, although permits are still being sold, that from the time the permit is issued to the time they start work on the well site is usually about 50 days, and most of the traffic is applied within the next 2 weeks. So we're talking about the majority of 120,000 easels being applied to that route within about a 2-week period of time. Now for an FM road, that might be, for a low volume FM road, that might be 20 years of traffic. For this state highway, that might be the equivalent of 5 years of traffic, but you're getting that in 2 or 3 weeks. So it's the obvious reason why we're seeing certain routes deteriorate so quickly, because not only do we have a lot of truck trips that are occurring over a compressed period of time, and again, this methodology helps us know where are the critical routes. So again, State Highway 21, 120,000 easels. However, there were no plans, no pavement plans within the 4-year plan scheduled for this section of roadway. But that's important information to know. The next one was FM 1624. Again, I won't go through all the calculations, but we came up with about 74,000 easels for this FM road. Of course, when you're thinking about the impact, we have to think about what is the existing pavement structure, what is the remaining life of that existing pavement structure, and how many additional easels are we now putting on that in a very short period of time. So 74,000 easels on this section of 1624, and there is a project schedule, but it's not a paving project, it's a safety project with guardrail and extend safety tree culverts. So that's an opportunity to think about, do I want to do something on this route within that section where I may be carrying an additional 74,000 easels. And then the final section is US 77. This is about a 10-mile long segment, and based on those same methods, we estimated about 94,000 equivalent single axle loads being applied to this section of roadway. And it does have a pavement project planned on it in 2018. It's a seal coat, a level up seal, and an overlay. So again, kind of looking at the big picture, and now this is looking at that region. This is within Lee County. We're looking at these routes. This is 1624, 1.3 miles long. It's going to get an additional 74,000 easels. It's going to have a safety project, but no paving is currently planned. Then we have another project which is 5.7 miles long, US 77, an extra 94,000 easels. And that's planned for 2018, level up seal coat and overlay. And then finally, State Highway 21, there are no projects planned for this segment of roadway, but it's going to get an extra 120,000 easels. So this provides Mike and the district with an idea of what is the impact of fracking going to be in this area, and how can that impact, or what can I do proactively to address this through my 4-year plan? Do I need to accelerate projects? Do I need to delay them? Do I need to add projects? So again, this is what Mike was looking for, and this was a case study that we conducted for him, and we can see other opportunities for expanding this to, again, commercial and residential construction, industrial construction, and other areas. So as I said, right now the price of oil is low. Back when we were doing this original work, it was up around $100 a barrel, and fracking was in full swing. Now it's less than $50 a barrel. And if you look at NASDAQ, many companies have to have about $80 a barrel before fracking is worth doing, although some can operate at 50. Right now, some fracking is going on, but it's not like it was a year and a half ago. So nevertheless, the information is there and available for the district to consider how they want to use that in their 4-year plan.